Hello all. In this video I am going to describe you the wireless power transmission with a practical example. This is the application of a wireless charging circuit. I am using IC555 as an oscillator. You can see here on the drawing IC555 as an oscillator. Okay, so the frequency of the output frequency of the 555 IC is a 45 kilohertz, and I am using two 1K resistance and a 0.01 microfarad resistance for this frequency chain. Okay, the pin number 5 of the IC is connected with a 0.01 microfarad capacitance. The pin number 4 and pin number 8 is connected to 12 volts DC bus. Okay, the pin number 3 is generating 45 kilohertz frequency, and I am using 10K resistance and an LED to track the output presence. The pin number 3 is further connected to a 220 ohms resistance, and finally it is connected to the IRF 840 MOSFET. This is the IRF 840 MOSFET. You can see this is the gate terminal. So the gate terminal is also connected to a 10 kilo ohm resistance to the ground. This is used to discharge the MOSFET gate capacitance because this is a high frequency circuit. So immediately within a cycle the capacitance has to be discharged. For this 10K resistance is required. Okay, the drain terminal of the MOSFET is connected to a coil. This coil is designated here in the circuit as coil 1. So this is just a few turns of copper wire. Okay, so there is another coil coil 2. So there is no coupling between these two coils. The air media is used as a coupling media. Air is used as a coupling media between these two coils. Okay, so this is basically the wireless charging concept. There is no contact between these two coils. Like as if this is your primary coil and your phone, inside the phone there is a coil that is a secondary coil. You are keeping the phone on this and the phone is charging. So this is the concept of the wireless charging. So now the output is connected to a Schottky diode and a capacitor, and finally it is connected to a 10 kilo ohm resistance and an LED. Okay, so the circuit I am going to show you how this circuit I have made on a breadboard. Okay, so once again I would like to say you the coupling media is, there is no contact between the two coils. Air is used as a coupling media. This is like an air core transformer, as you can say. Okay, so now I am coming to the circuit. So as you can see on the circuit, this is your coil. This is your primary coil. This is the coil number 1, and there is another coil is there. I will show you. This is your coil number 2. See, this is your coil number 2. Okay, this is your coil number 2. This is the second coil. Okay, so now I will show you the circuit on the breadboard. So this is your 555 timer IC. As you can see, this is your 555 timer IC. The two 1 kilo ohm resistances you can see, and 0.01 microfarad. This is the capacitor. Okay, and on the pin number 5 you can see this is the 0.01 microfarad capacitor again on pin number 5. The output pin number 3 is connected to this 220 ohms resistor, and the output again is connected to an LED and a 10 kilo ohm resistance on the DC bus. Okay, so this pin number 3 output is connected to the MOSFET. This is the IRF 840 MOSFET, the gate of the MOSFET, and the drain of the MOSFET is connected to this transformer. You can see this wire is going to the transformer. So you can see this is going to the transformer. Okay, you can see this wire is going to the transformer, and the another wire is connected to the DC positive DC rail. Okay, so this is the circuit primary. The primary of the circuit is like this. So here you can see the primary coil. This is the coil number 1. As you have seen in the circuit, this is the coil number 1. Okay, so now coil number 2 is here. This is the coil number 2. Okay, basically these are few turns of copper wire. I have purchased 2 copper wire rolls from the shop, and I am using it in this way. This is like, you can say, 1:1 transformer. Okay, so this coil output is connected to this circuit. You can see here there is a Schottky diode. I have used one Schottky diode. So this is a Schottky diode because this is a high frequency circuit. It is 45 kilohertz. So normal diodes we cannot use. We need to have a Schottky diode. Okay. So yeah. So and this is the filter capacitor. So for now I have used 47 microfarad 450 volts capacitor. Typically 1000 microfarad and like 63 volts capacitor better to use typically. Okay, so now you can see I am using an LED and a 10 kilo ohm resistance to see the voltage presence. Also I am connected with a multimeter. You can see here the multimeter is showing some voltages. This is the Schottky diode voltage. Okay, so we no need to worry about this voltage. So now I am going to bring this coil. This is the coil number 2. As you can see here in the circuit, see this is the coil number 2. Here this is the coil number 2, and this is the coil number 1, and here is the coil number 1. Okay, so now I am going to bring the coil number 2 near the coil number 1. You will see the LED will start glowing. See, you can see the LED has started glowing and a voltage has developed, 5 volt has developed, but still the two coils are not above each other. Okay, still there is no coupling, no good coupling, but still it is detecting some voltage. You can see it is still detecting some voltage. See, still the coupling is not good, but the LED is on, and here you can see still the voltage is 6.18 volts DC. Okay, so now I am going to make a very good coupling. I will place one coil on the top of the other. So now you can see one coil is on the top of the other. See, one coil is on the top of the other. The LED is glowing. You can see here. The LED is glowing. This is the filter capacitor, the secondary circuit, as I have said. Okay, and you can see here the voltage is 11.53 volts DC. See, it's 11.53 volts DC. I will shift the multimeter to AC scale. There is no AC. There is no ripple. The secondary filtering is very good. Okay, so see here it is 11.5 volts DC. This is because this is a 1:1 transformer. The two coils I have purchased from the shop, they are having same number of turns. That's why this is basically a 1:1 transformer. The power rail is a 12 volt rail. So here on the secondary I am getting 11.56 volts. Okay, so this is how the two circuits are being coupled. So if I remove this coil from here, you can see I have removed. The voltage is not there, no voltage presence. So when the coil is here, it's giving 12 point something voltage, 12 point some volts. Okay, so this is how the circuit is working. So we can say here the coupling media is air. Between the two coils, the coupling media is air. Okay, this is a air core transformer concept. Okay, this is all for today. Thanks a lot. Please perform this experiment, and thank you very much. Please like, share and subscribe my video. Thank you for your support.